Thanks for allowing me to insert the final chapter of Alma's Almanac, Dr. Rob. Class, the last few innovations we'll review together relevant to this session is the proprietary unipolar RF and the non-focused ultrasound on the AccentPrime. Since its debut in 2007, the sheer novelty of Alma's unipolar RF in the category of radio frequency technologies has led to a number of clinical studies that document the distinctly different mechanism of action of unipolar RF when compared to monopolar and bipolar RF. Monopolar and bipolar RF uses an electromagnetic energy range of 1 to 7 MHz. While the energy path and depth may differ, both share a similar mechanism of action. The electric current generates heat as a result of tissue resistance. This heat causes an inflammatory response, with subsequent contraction. In comparison, unipolar RF does not deliver an electric current to the skin. Instead, it uses high-frequency electromagnetic energy at 40.68 MHz that excites water molecules to rotate, causing friction, which in turn creates heat. This heat dissipates to the surrounding tissue, reaching depths as far as 15 to 20 millimeters. Why does this matter? The depth and volume of the heat distribution will depend on the type of radio frequency you use. With unipolar RF and bipolar RF on the AccentPrime, you have the full range to deliver therapeutic heat to the desired depth and volume. To complement the tissue temperature elevation properties of radio frequency, Alma introduced non-focused ultrasound in 2016. Ultrasound traditionally uses a one-directional pressure wave to cause microscopic gas bubbles to expand and explode, also known as cavitation. However, in a high-pressurized environment, like that found using focused ultrasound, the cascade of shock waves from these micro-explosions raises temperature, leading to non-selective residual damage in the treatment zone. Alma's ultrasound introduces multidirectional waves that alternates. That's less thermal and traumatic. The hot mode, or compression waves, that's commonly used in most ultrasound devices, oscillates particles, liquid or solid, parallel to the wave. That leads to cavitation. The cold mode, created by shear waves, oscillates particles, solid only, perpendicularly to the wave. The cold mode does not cause cavitation. Instead, stretches and relaxes the cell to denature its structure, making it more permeable. AccentPrime, along with many of the innovations we've reviewed over the past 20 years, share a common philosophy: to pioneer meaningful change. Some of those changes were big and bold ideas, and some were found in the details. But every change, big or small, was intended to improve the clinical experience for Alma's customers and their patients. Dr. Rob, now back to you.